All right, on page 655, number 15, says the isotope most commonly used in a PET scanner is fluorine 18. Okay, so a PET scanner is a positron emission. So it's injecting you with something that's going to give off positrons, and then the scanner's going to pick them up, and it's going to help to get images of your body. What element is formed by the positron emission of this element? Write the equation. Okay, so to make it, the fluorine would have already been bombarded with something so that it would have become fluorine 18, and it's positron emission, so it's giving off a positron and a neutrino. On the top has to be 18, on the bottom has to be 8. Look 8 up in the periodic table and discover it's oxygen. So what's given off is oxygen. That's part A. Part B is the reaction, and part C says the half-life of fluorine 18 is 110 minutes. A solution containing 10 milligrams of this isotope is ejected into a patient at 8 a.m. How much remains at 3:30? Okay, so the half-life, T1 half, is 110 minutes. M initial is 10 grams. And it says 8 to 3:30. So that's 7.5 hours. So 280, 7.5, oh, wait, let me do that again, 450. So delta T is 450 minutes. So we can find the number of half-lives because we know it's delta T over T1 half. So it's 450 over 110. And when you do that, you get 4.09 repeating. So now we go to our MF is equal to MI over 2 to the N. So MF is equal to 10 grams over 2 to the 4.09. And you should get an MF of 58683 grams. Okay, so that's number 15. Number 16 says the basement of many homes contain rock granite that are built over granite. Granite contains small amounts of radioactive uranium and thorium. Uranium-238 goes through a series of decays before reaching a stable lead isotope. Uranium-238 emits an alpha particle, leaving an isotope that decays by emitting a beta. The next decay is another beta, followed by 3 alpha decays. The result is gas radon that can seep into the basement. Write the equation. So really what they're talking about is the uranium disintegration series, that chart that you have in your notes that you'll be using in some of your multiple choice questions. Okay, so uranium-238, so it says first it gives off an alpha particle. So there's a 4,2 alpha here. The top then must be 234, the bottom must be 90. Look it up and you see it's thorium. So then thorium-234 90, and you have to write it as a separate equation. Used to have people that would keep going equals equals, but it isn't because this part is gone. It's getting fired off. So you have to start again. So thorium, it says it's given off a beta particle, which is a -1, and I'll write the beta instead of an electron just for fun. And remember beta, so it's giving off as well an antineutrino. On the top must be 234. -1, this must be 91. And when you look 91 up, it's palladium. So then 234, 91, palladium. And it says it undergoes another beta. So another -1 and a 0, 0 antineutrino. On the top must be 234. On the bottom must be 92. You're back at uranium again. Okay, so then 234, 92, uranium, it says now it undergoes 3 alpha decays. And separately, like not all at the same time. So the top's going to be 230, and it's going to be 90, So, whoops, that's thorium. Sorry, jumping ahead of myself. Thorium. And then thorium undergoes another alpha, so 234.90. And it's given off. And now you might wonder, how come thorium up here gave off a beta particle, and down here it's giving off an alpha? Because it's a different isotope. Right here it was 234. Maybe it's not a different isotope. Oh, okay, take it back. It's the same isotope. Sorry about that, I lied. 230. No, it is a different isotope. I just wrote the wrong number down here. Good. It was supposed to be a different isotope, and I couldn't figure out why. So now it's going to be 226, and take away 288. And when you look, 88 should be radon. And then the 226.88 Ra gives off another alpha particle, leaves you with 222.86, which is, one's radium and the other's radon. Sorry, I think I said radon for the top one. Okay, and that's number 18. Actually it's number 16. I can't make up my writing. Number 17, the first atomic bomb released 1 times 10 to the 14th joules of energy. What was the mass of the uranium-235 that was fissioned to produce it? So they're telling us the energy. Man, I can't write in a straight line some days. So they're telling us the energy is 1 times 10 to the 14th joules. Okay? And it wants the mass. Well, we know E is equal to mc squared. So M should just be equal to E over c squared. So M should be equal to 1 times 10 to the 14th joules over 2.9979 times 10 to the 8th meters per second squared. And when you do that, you should get an M of 1.112668 times 10 to the negative 3 kilograms. So 1 gram? Number 18, complete the following. So this is a fission, and it's 239.94 plutonium, and you're shooting in a neutron, and it tells us that we're getting out 137.52, which is technetium, and 3 neutrons. So on the top would be 140 on this side, and it has to be 240. So this has to be 100. On the bottom it's 52, and over here the bottom is 94. So this has to be 42. And when you look that up in the periodic table, it's molybdenum. All right, I think number 19 is similar, but it's uranium maybe. So uranium 235.92. Again, you're shooting in a single neutron, and it's telling us that we're getting out krypton. So 36 Kr, and we're also getting out 3 neutrons. So again, on the top it would be 95, and over here, so it has to be 140 to add up. On the bottom, 36 and 92, so it should be 56. Look 56 up, and it's Ba. Okay? All right. Number 20 says, plutonium is formed in 2 steps. First, uranium-238 absorbs a neutron, which then becomes unstable 239. 239 emits a beta particle, forming a new element, and this new element emits a second beta particle, forming plutonium. So complete the following reaction. So uranium-238, 92, plus a neutron is going to go to 239.92, which I'm putting it like that because it doesn't last very long. and then it says it emits a beta particle, and of course an antineutrino.